This week we are going to discuss the brain-gut-thyroid axis and its role in inflammation, and specifically how the thyroid's role in the axis helps prevent systemic inflammation. And this is piggybacking on last week's video where we discussed the topic of why are you still inflamed even though you've done everything appropriately in terms of putting out inflammation, or maybe you haven't done everything appropriately, but you've tried everything that medicine has to put out inflammation. And so I refer you to that video to get, say, the part 1 of this. And that video talked about how you could have genetic mutations in proteins that code for inflammatory cytokines that make you more inflamed than the next person, and also make you respond or make anti-inflammatories less powerful against your body. So I refer you back to that, and we'll piggyback onto that in today's video. So let's switch over to the whiteboard because we're going to get artsy again. So let's first start by drawing some physiology. So we're going to start up here with a brain and a brain stem. We all have one. We all should, right? And then floating out in front of the brainstem here, because this is about where your neck is going to be the thyroid gland. Butterfly-shaped gland in your neck. So to kind of give you an orientation, the eyes, the nose, mouth, chin would be coming up that way. So you've got the thyroid right under the chin there. All right. And then up here in the brain, we have the hypothalamus, which is the thermostat for the brain. It's sensing temperature and hormone levels and all kinds of things. And then coming off the brain here is the pituitary gland. And so the hypothalamus is the thermostat sensing hormone levels out in the body, say thyroid hormone. And if there's not enough thyroid hormone, the hypothalamus will tell the pituitary, the thyrotropin releasing hormone, TRH, it'll tell the pituitary to tell the thyroid to make more. And so then the pituitary will secrete TSH, thyroid stimulating hormone, to tell the thyroid gland to make more. And then the thyroid gland will take iodine and tyrosine, and it'll make T4, a thyroid hormone. Okay. So that's the upper part. We're going to tie all this together, but I wanted to give you that right now. Then from the brainstem, or you've got the brainstem there, and then the brainstem, when it leaves the skull, becomes the spinal cord. We'll talk about that later. But in front of that, in the throat, is the esophagus here, running down. And the esophagus connects to the stomach. Okay, and then the stomach connects through to the small intestine. First, we have the large intestine here. Large intestine. Okay, and with the rectum there, that's the large intestine. And inside there's all the squiggly small intestine, right? And over here on the right side of your body, you've got the liver. And over here on the left side of your body, you've got the spleen. Okay, so we'll call this large intestine. We've got the small intestine over here. Okay, and this is the stomach. So that's the anatomy we want to be familiar with for today's call. And so, again, we've got the brain, and the brain, the hypothalamus talks to the pituitary, which talks to the thyroid. The hypothalamus is the thermostat, and it's sensing thyroid hormone levels in the body. When they're too low, it tells the pituitary with thyrotropin releasing hormone, hey, tell the thyroid stimulating hormone, to make more thyroid hormone. The thyroid will do that. Thyroid hormone sets your metabolism. It sets the metabolic rate of every cell in your body. So for you to grow hair, skin, or nails, for you to not have brain fog, for you to lose weight, for you to not be constipated, for you to do anything you need to do, you need thyroid, because that's setting the metabolic rate for you. Okay. So if you have a lack of thyroid, you have a lack of those things. You might have hair, skin, and nail problems. You might have brain fog. You might be constipated. You might have heart rate or rhythm issues. You might have difficulty losing weight. You might have cold hands and feet. There's lots of different symptoms depending on which cells and tissues are feeling the lack of thyroid. And one major way that the thyroid contributes to GI function is that it promotes secretion and absorption of enzymes and stomach acid, etc. But it's also key in promoting vagal nerve function or vagus nerve function. Okay, so I'm going to draw the vagus nerve using blue. And the vagus nerve comes right off here, right off the spinal cord where it meets the medulla or the bottom of the brainstem here, is the C1 nerve root, which is the vagus nerve. And the vagus nerve, supplies the GI tract, and it promotes peristalsis. So it supplies the stomach and promotes gastric peristalsis. Okay, please mute yourself. If you just joined, please mute yourself. So the vagus nerve promotes gastric peristalsis. It promotes small intestinal peristalsis. Okay, so it promotes movement. That's moving food through the GI tract. If you lack vagal motor outflow, you become constipated. Okay, well, what the vagus also does is it promotes spleen. Okay, and it promotes, like we said, small intestine inhibition of the pro-inflammatory cytokine tnf-alpha. Okay. TNF-alpha. So you've heard of TNF-alpha before, right? We'll talk about where. And the vagus also inhibits liver production of another inflammatory cytokine called interleukin-6. So when the vagus is working properly, it will be anti-inflammatory and inhibit that. And so some of you might be saying, whoa, this is connecting to last week, right? Because last week we talked about how interleukin-6, IL-6, and how TNF-alpha, tumor necrosis factor alpha, are pro-inflammatory cytokines, or chemicals that promote inflammation by increasing liver production of C-reactive protein, right? Or CRP. And you'll remember that CRP is the #1 inflammatory marker that doctors all over the world run when they want to know, is somebody inflamed? Okay. So the vagus nerve, last week we talked about, when you're chronically inflamed or chronically infected or have chronic autoimmune disease, and you've seen the rheumatologists and endocrinologists and pain doctors and orthopedists, and you've done the medications and you've done everything they had to offer. You might have even seen functional medicine doctors and naturopaths and the best natural doctors, and not got better, not received benefit. You're still inflamed, you're still in pain, you're still beat up. And in last week's video, we talked about, well, maybe the reason for that is that you have genetic mutations in the genes or in the alleles that code for IL-6 and TNF-alpha. And if you have gain of function mutations in those alleles, you're going to make more CRP than most people, and so you will be more inflamed. And so what we wanted to do is, remember, we can't change your genes, but we can impact the expression of those genes. Remember, genes load the gun, environment pulls the trigger. The environment is your lifestyle and your choices, etc. So if we can change your lifestyle and make choices that are anti-inflammatory, we can impact genetic expression and help those people in the chronic pain have decreased production of these guys and be in less pain and less poor health. So one of the questions that always comes from that is, well, what can help us do that? Well, this video is showing you one way to impact those from an anti-inflammatory standpoint, and that is the vagus nerve here. You can see the vagus nerve, when functioning properly, when you're having vagal motor outflow, it's called, or the vagus is sending signals down, vagus will cancel or inhibit liver production of interleukin-6. It inhibits small intestine production of TNF-alpha, inhibits spleen production of TNF-alpha. So if you've got a properly functioning vagus nerve, that's providing a huge anti-inflammatory stimulus in the GI tract, and that's a huge anti-inflammatory stimulus systemically, because gut inflammation drives systemic inflammation, which drives neuroinflammation. So if we can put out fires in the gut, we can drastically decrease someone's inflammatory levels, regardless of what genetic promotion they have of that inflammation. Even if the genes are upregulating the production, the better our vagus nerve functions, the more we can offset, inhibit, abrogate that inflammation. So it's huge to have optimal vagal motor outflow. And so we want to see that. And one big thing that promotes optimal vagal motor outflow is thyroid function. Okay. So what we want to look for on testing, remember, TSH is the one marker that conventional medicine always runs to test thyroid. There's really 8 markers in a full thyroid panel, but conventional medicine typically runs 1 or 2. The second one would be free T4. But every doctor is going to run TSH to test thyroid. And the normal range for thyroid, the quote lab normal range, is 0.45 to 4.5. If you look at your LabCorp, normal reference range on the side of the paper, it'll say that. Well, if you're anywhere in that range, conventional medicine is going to say you're fine. From a functional medicine standpoint, you want to be more in the range of like a 1.8 to 2.5. Okay. So if you're above that or below that, even though you're in this normal range, quote unquote, you may have suboptimal thyroid function. Well, there's a lot of people walking around that are on thyroid hormones that have a TSH of less than 1. Okay. So they're in the 0.8. And again, they'd be told that that is good. But TSH is driven by TRH. Remember, TRH tells the pituitary gland to release TSH to tell the thyroid to work. So if TSH is too low, that suggests that TRH is low. And TRH promotes vagus nerve function. So we could use a TSH marker in people to get an idea of what TRH levels are. And if TSH is low, suggesting TRH is low, and then in the patient's specific clinical case, they're chronically inflamed and they're having, say, constipation issues, or they're having digestion issues, gas, bloating, IBS, that sort of thing, potentially that TSH that everyone's calling normal is actually too low and contributing to poor vagal motor outflow, contributing to their inflammation, their constipation, their bloating, etc. So that could be whether they're on thyroid medication or not. Okay, so we want to, again, this is a new way of looking at thyroid testing to get an idea of what brain is doing and nervous system control of inflammation and digestion is doing and how it all wraps together. So again, we don't want to see a lowish TSH and just say this is happening definitively. We need to look at the testing in the context of the clinical case and symptoms and history in front of us to get an idea of that. And then we also want to look at a person's genetics. So if the person, say, is in the chronic pain, chronic inflammation, chronic autoimmunity, and they have the gene mutations that we talked about last week in the IL-6 and the tnf-alpha genes causing upregulated inflammation, then, if they've got those genes and their TSH is on the low end, then it's likely that not only are they upregulating the inflammation, but they're also lacking inhibition of the inflammation here. So that could be a double whammy. So if we don't change their genes, but we can improve their TSH level, that would suggest we've improved their TRH level, which would improve their vagal inhibition of the inflammation. Now, for the vagus to work, the vagus requires acetylcholine. The vagus is what's called cholinergic, and it uses the neurotransmitter acetylcholine. Well, acetylcholine requires choline to be made, okay? And you get choline from eggs, is a great source, egg yolks specifically. And what? Conventional dogma says don't eat eggs because you'll die of a heart attack, right? Well, that's wrong. If you don't eat eggs, you'll die of inflammation from lacking vagal motor outflow. But anyway, we need choline in our diet. And the choline gets converted to acetylcholine, and acetylcholine allows the vagus to have its impact on the end organs. But here we go again with genes. There's genes here. There's two that are important. There's one called PEMT, and there's one called MTHFD1. And both of these genes function for acetylcholine status. Okay, so if you had SNPs or gene mutations in these genes that are a loss of function mutation, causing these genes to be downregulated, which would downregulate or cause a lack in your acetylcholine status, then that downregulates your vagus function here, which would result in a lack of inhibition, which would be pro-inflammatory, right? It would cause a relative upregulation of your inflammation. So here's a way that, say you don't have these genes for inflammation, say you have the normal correct genes, right? So you're not overproducing inflammation, you've got the normal genes for inflammation. But then say you have the mutation over here which causes downregulation of acetylcholine, which then promotes poor function of the vagus. Now you could have relatively increased inflammation because of the genes over here. All right. Say you have these SNPs and these SNPs. Well, that's a double whammy for a pro-inflammatory environment. Okay. And you have, say you have these SNPs, and a low TSH, suggesting low TRH, triple whammy. Okay. Say you have all that and you eat a poor diet and you don't sleep and you don't exercise, et cetera, et cetera. So you could see how the lifestyle could just, even regardless of the gene makeup, could drive a very pro-inflammatory, pro-pain, pro-inflammation, pro-autoimmune state. So I hope this didn't confuse you too much. The take home that I wanted you to get is that last week we talked about inflammation, and we can't change genes. So if you have those genes that upregulate inflammatory production, we can't change that. What we can change is the expression of those genes. The expression is driven by lifestyle and choices. So if we have a thyroid that is not working well, or that is not managed well, and we think we're doing well because our TSH is low, but knowing that TSH gives us a picture of what TRH is doing, and TRH drives vagus function. If our TSH is too low, that may suggest vagus function is too low. So then your anti-inflammatory result from that could be low, promoting inflammation. And we need acetylcholine for the vagus to work. If we have mutations in the genes or acetylcholine status, that could drive our vagal function down. If you've had a head injury, that can affect your vagus function. If you're stressed, stress inhibits the vagus, okay? Because stress is that fight or flight response. You're running from a tiger. The vagus is the opposite. It's the parasympathetic, the rest and relax response. You can't be fighting and flighting and resting and relaxing at the same time. Okay, so if you're fight or flight, you're inhibiting that rest and relaxation. You're inhibiting that vagus, which promotes inflammation when it's chronic. So getting on top of your tigers or handling your stressors is a huge way to positively deal with this whole situation. So the take home is we want to be optimal in our thyroid function, because thyroid is going to impact vagal nerve function. Thyroid is going to affect metabolic rate of every cell. Thyroid, through those mechanisms, affects your inflammatory status. Let's open this up for questions and comments.
I always love your pictures because it just reminds it just blows my mind that people just operate the way they do conventionally, and everything has to go down this little bitty tube and that's it. It's not connected to anything else. And everything is connected. Everything.
Yes, that is correct. And hopefully, even though these can be confusing, hopefully it helps you understand why a medication isn't working, right? Because, go here. So typically a medication, we'll call it a prescription. So RX is what we'll use for that. So usually, you know, in conventional medicine, they're looking for one thing wrong. A is what's wrong with you. And so we give a prescription to change A so that your symptoms go away. And in this very simplistic model there, that should work and you should be good to go. But
it's all that crap.
But there is no in chronic cases, at least, A is not happening alone, right? There's A, there's B, there's C, there's D, and there's no drug that addresses all of those at once. And that's why you see people on 4 different drugs for those 4 things. Well, the cool thing about natural things is that many natural things are Swiss Army knives and hit many things at once. So it's possible that there is an herb that could hit all 4 of these, maybe not equally, but impact all 4 of those things. Maybe there's a couple herbs that could, and then maybe even act synergistically on one or more of these while acting individually on the others. And so, you know, conventional medicine doing the give this for that, just swallow this down this little tube, you know, they're limited by that, and therefore the paradigm's limited. And so you have to see 4 different people for 4 different conditions, whereas if we could just zoom out and understand the global physiology, we can address it more efficiently and effectively.
You also mentioned the head injury, and that was actually, I'd written this down. My question is because of the TRH and everything that it does. So head trauma could definitely impair this process, right?
Oh yeah.
Okay.
Oh yeah.
Okay.
So through the what's called the brain-gut axis. Okay.
Yeah.
And so
Okay.
research shows that within 6 hours of a concussion, you could have leaky gut. Now, is that happening in every concussion? No, but it's possible. And the one big reason for that is you hit your head, okay, brain becomes inflamed. Now it's a big time stressor situation. You're swinging away from parasympathetics and vagal stuff to sympathetics. And then also the head injury, you know, inflammation is going to inhibit the vagus. There's multiple ways that the head injury leads to poor vagal function and vagal motor outflow. So now that could lead to GI inflammation, poor barrier function, permeability, and you're off to the races.
This is incredible. I love this so much.
And another point there is the head injury doesn't have to be like an obvious, you know, concussion, like a football, a hit in football, or a backflip that landed wrong. A head injury could be chronic stress. Okay, so again, it might vary in intensity, but if you're chronically stressed, you're still inhibiting the vagus, which can then have the same result over time, just not as acutely, right? And that's far more common. So that'll never be diagnosed as a concussion or even as a head injury, but it is brain gut axis dysfunction.